G'day guys, how's it going? So in this video, we're going to look at submodules in Rust as well as paths, or what we call paths. So firstly, what is a submodule? Well, it's pretty simple to understand. It's really a module that just sits inside of another module. So for example, I have a module here that's called A. It has one function in it, but just below that, I can actually create another module and call it, say, B. Right? And we can take the exact same function from A and we can pass it into B. And this will work okay because it's in a different module, right? So that's the one thing to understand. We can have functions of the same name as long as they're in different modules. Now, you might be asking, well, how do we call this, right? This is where paths come into picture in Rust. So I have one call already down here, which is a colon colon and then print module position, which comes into our module and it prints this print module position, right? Now, if I want to get to this print module position, I have to go in the module B. Therefore, I have to traverse the path of the modules. So module A is the root module for all of this code. And then the following one is B, right? So to do this in Rust, we basically go down the tree just using those double colons, right? So first we hit A, then we go to B, and then we go to the name of the function. So in this case, it'll be print module position. Now I'll save this and everything seems to be okay, but we do get a little error, right? And that error is because the module or this submodule is not publicly available outside of module A. And that's because we too need to make this public. So we do that by just putting the pub keyword there. And once I do this, we can now run this code and we can see, well, other than I didn't rename that letter there, if I run it again, we can see that we are now in module A and we are in module B, right? Because we traversed through module A into module B and we called print module position, which printed this function. Cool. So obviously we can continue to do this. We could have, say, another module and we could call it C, like so. And I could change this to C. And then once again, the same relative path would be similar to what it was called for B. So instead of going A colon B, colon B, we go A colon C, and then call print module position, right? And that would give us, well, you probably guessed it, we are in module C, right? Now, obviously, some modules can have their own submodules. So far we've only got, a submodule of A. Well, B can have a submodule inside of it as well. So if I take the contents of B and I paste it inside of B, and then say, let's rename this to D and D. If I try to call this, how would I do it? Well, you're traversing those modules, right? So I would pretty much grab the one that's at B and just change it a little bit to include. Then now we're going to go into D and call its print module position and run that. And you can see it hits module D. Same deal for C. We could do the same thing. And this is, I'm just kind of repeating a little bit here, but just to give you a better understanding, just do it a few times. So mod E, and then pretty much I'll just copy this and change it to A, C, and E, and save and run. And there we go. Cool. Now, these paths are all relative to main at the moment. So we're calling these from main. So that's why it starts at A, goes to B, goes to C, or A to C, and then A to B to D, and A to C to E. But what if we wanted to, say, call one of these functions from a module within here somewhere, right? So let's say, for example, that we wanted to print C's print module position from module A, right? We might create a function to do that. So we could do something like pub function print C module position. Right? So how would we get to C's module position? Well, it's relative from A. So what we would do is, well, we'd say C colon print module position. Why is this? Well, C is a submodule of A, so we just need to refer to it relatively here, and then we can call its function. Cool. Hopefully that makes sense. And we can do the same, say we want to reach D. D's a little deeper down. Inside of B here, it's down here. Well, we could do something like this, right? We could go, we're going to go into the module B. We're then going to hit module D, and then we're going to call its print module position. Cool. So if I now come back to here, in order to call those functions that we just created, we're only really going as far as module A, right? So let's go A colon print module C position and A colon print D module position. And hopefully the last two should say C and D. And they do. Cool. Now we could continue doing more of these. So we could say something like from within B, let's call D. So I'll just grab something similar to this. And within B, well, hopefully you've guessed it. I don't really need to use B colon D. I just have to go D. And then basically I can call that down here as well. So I can go, whoop, sorry, my bad. A colon B colon print D module position. And I think you're starting to get you're starting to understand what I'm talking about here, right? Cool. So that is basically going from the top and down through the modules, right? So we're going from the top module and we're making our way down. But what if there's a situation where, let's say in E, I want to start printing out modules from further up, right? So maybe I want to do one from, let's say C, right? So we would do something like this, right? We come in, we go pub, fn, print, let's say parent module position, like so. Now, how would we call C's print module position? Well, you might say, well, we call C, right? But we can't do that. And the reason why we can't do that is because when we put the C here, it's going to look inside of this module for another module named C, right? It's not going to go up and go, oh, I see there's a parent C. It's going to look for a submodule called C. So we can't use that, right? We can't use C. So what Rust has is something called super. And this basically means go up one module to the parent and then call whatever function that's there, right? So now in this case, I can call print module position. Cool. And now if I try to call this, so once again, we're going to go A colon C colon E colon print parent module position. And hopefully this will indicate that we get C, right? And there it is. Cool. So that gets us up one level, right? Well, what if we want to go up more than one? What if we want to go all the way back up to A, right? Well, it's not much more difficult than this. We could do the following. We go super and colon, right? And I'll just call this grandparent. So there's another way of going up 2 levels, right? So then I just have to test this out. And we'll just grab the prefix here, the front of the function. So from the E module, it should now print A's print module position, and it does. Cool. So for the most part, they're the main ones you're going to, or the main ways you're going to refer to modules in paths. There is one other way And that is if you want to call yourself, there might be times where you want to refer to the same function within the same module. So you would do something like this. You go pub, fn, let's say call parent, call adjacent module position. And in this situation, we just use the word self, kind of like we have for structs before. So you go self, and then you just call print module position. Cool? And this would work as well. So let's just quickly test it to make sure it does. So A, C, E, call adjacent module position. Save, run, and there you go. It prints E. So that is it for this video. Just understand, basically, modules can have child modules, which are called submodules. And in order to communicate between them, we have to have relative paths like this, or we can, if we're in a child module or a submodule, you can use the super keyword, or self if you're calling within the same module. Cool. So that's going to end the video here. So thank you for watching, and I'll see you all next time.